Welcome and hello. This is a video lesson in RIMS, and in this lesson, we're going to be dealing with comparing alternatives. That is, comparing one specific set of model results with another set of model results. In this lesson, we'll demonstrate how, after running a model, we can arbitrarily change a specific model variable's value and then rerun the model again at that time step and evaluate how that change affects everything else in the model, such as the decision variable values and the objective function value. All right, so let's go ahead and get started. I have the RIMS interface up right here. I have a very basic model schematic you see with a single reservoir, an inflow, a downstream channel labeled C12, and then a downstream demand labeled D2. Okay, so that's all we're working with here. I'm going to go ahead and just run the model. I'm not going to go into too many details. I go ahead and open up the launch file, right click on the launch file, run as. Okay, that ran. It's a 1 month time step over a 10-year simulation. Here's the decision variable values. So let's refresh the catalog. And then here is the reservoir oscillating in volume over the course of that 10 years. We also have the flow in the downstream channel. So here's that. Next, what I'm going to do is set the debugger to stop a couple years into the simulation and then force one of the values for this channel flow to be different from what it is. So we're going to focus on September 1923. Let's go back to our RIMS now. And up here at the top, I'm going to select the year 1923 and then September. I also need to say cycle 1 because I only have one cycle. All right, so with that set, I will right click on the launch file, click on debug as, and then wait for the first 2 years to run, and then it should pause for me. Okay, so it says pause down here in the console. That's good. Next, I'm going to open up the channels file, which is where I'm keeping track of the channel data. So over here in the left panel, I'll expand system channels.russell. It is right here. C12 has a value of 49.8694 CFS for that month. That's the average flow, and that's September 1923. What I'm interested in doing is arbitrarily setting this channel flow data to a different number. We'll say 60, so there's more flow out of the reservoir just for that month, about 10 CFS more than it currently is. What I'm going to do is go up to the data menu right here and then click on save to DV file right here. And then what it is it's asking me to specify a path to the DV file. It's currently db.dss. I could just say okay if I want to overwrite the current db.dss file. I don't. I'm just going to call this test and then click OK. So that's saved. Now, if I go to my DSS view and then open up, I have this dv.dss, that's the original, and then dv test right here. If I open that up, now I have a new set of decision variables, and this only goes for the first 2 years because we just stopped right here 2 years into the 10-year simulation. Okay, next I'm going to go back to RIMS and I'm going to load that newly created dv_test.dss as my alternative 1. So I want to go up to the data menu now and then click on load DSS/studies. This dialog box allows me to load up a number of alternatives and then select the decision variable file and the state variable file. So I'm going to click on this alternative 1 checkbox, and then I can, I guess, just browse. Yes. So I'm browsing and I'm going to select dv_test.dss. So this is serving as my baseline, my original, even though it's called alt1. I'm kind of doing this backwards, but it's all right. And then for the state variable, I can browse and click sv.dss. But one thing I saw in the video that was pretty cool is that RIMS also allows you to just drag and drop the file. So here's the sv.dss file. I should be able to just drag and boom. Okay, cool. So that's just another way to assign the files if you don't want to use the browse button. All right, so that's good. I'm going to go ahead and click OK. And then over here in the side panel here, we have the values of the variables. So C12 is what we're interested in. Its value is 49.8694, and then we have a bunch of other values as well. Keep in mind, this is for the current time step of September 1923. And we can also hover over the variable here. It'll tell us the value for 49.86 is for both the value and the alt1. So alt1 is now reading in from that alternative file, which is our baseline. What we're going to be doing in the current model is overwrite the flow through this channel C12 and then simulate just this one time step and then make a comparison. So to do that, I'm going to open up my constraints file. Let me move this out of the way a little bit. We have channels right here. Bring up the constraints. Okay. Again, we have our channel C12 and a few other constraints. I'm just going to come down here to the bottom of the file and then paste in this constraint right here. And then what I'm doing is setting C12, that's the name of the goal, but C12, I'm setting it to 60, and it's for just this one time step. All right, so right here, I have the values. These are all the variables. So we have the variables tab, goals, all variables, all goals. If I click on variables right here, what we're seeing is a comparison between the values that are currently being computed and then the values read in from the DSS file, which is called alt1, and then the actual name of the variable. So at the moment, these two are the same, but once we save that constraint and then rerun the model in the debug mode for this one time step, what we should see here for C12 is that the value increases up to 60 because that's what we're setting it to here. And then some of the other variable values may or may not change as well. So let's go ahead and do that. Make sure to save all. And then to run another time step, I'm going to come up here to run, resimulate. And then I'm going to, oh, this is important. Make sure to click on this checkbox, recompile RESTful code. And then, yeah, the first cycle that we're on, that's correct. So just go ahead and click OK. Cool. So what we see now is updated values for this column under value. Of course, our C12 has correctly been assigned to 60, and it used to be 49.8. And then it looks like down below here, the C12 extra has also increased by about 10.2 CFS, probably about the same amount. The minimum is still the same. That's the minimum in-stream flow demand. And it looks like everything else is the same. Okay, so the reservoir storage is a little bit less. That makes sense because if we're releasing a little bit more flow rate over the course of that month, then the resulting reservoir storage at the end of that month will be a little bit less. So I'm looking at 55.49 compared to 56.1. If you're not seeing all the variables, for instance, this is just the variables in the selected file. But if you wanted to see more variables, we can move this over, click on the All Variables tab, and then click on this D button here, which would force, there we go. It basically brings in the data from the alternatives. So sorry, I probably should have said that earlier. We can also click on this W button for weighted variables. And what that does is it brings in all of the variables in this model that have either an objective function coefficient assigned to them or are involved in a soft constraint since there's a penalty. Now, it looks like there's no change in the objective function value for any of the variables except for the storage in reservoir 1. So if I open up my objectives function, which is right here, you see we're trying to maximize the flow C12 min, and that has a high weight of 20. However, it does have a ceiling, which is the maximum demand. And then after that, we're trying to maximize the storage of the reservoir, which is variable S underscore res1. So the reason why we have a negative value, let me click on this W again here. The reason why we have a negative value right here for the objective function value change as a result of increasing the release from the reservoir for that 1 month of September 1923 is because it results in lower storage in the reservoir, of course, and that is the difference here between 55.49 and 56.1. So that difference there is this difference right here, quite simply because we're using a multiplier of 1. So math is pretty easy. All right. Now keep in mind that this had the lowest weight. Here's the 20 weight from the satisfying the in-stream flow demand. And then the 5 and -5 values right here would be penalty if we happen to not satisfy this soft constraint, whatever that is. So that is one way how to change a specific value in a specific time step in your model, rerun the model, and then compare the base case versus the alternative. Now, in this case, I have alt1. This is really the base case, and then the value here is really my alternative because it's in this scenario here that I'm forcing 60 CFS, but that's all right. We could just swap it next time. Okay, I'm going back to RIMS. I'm going to click on the terminate button. What I want to do now is do a similar situation where I'm setting that channel flow to 60 CFS for just the month of September 1923. And then I'm going to run a base case and an alternative 1 case, and then compare the data using DSS view. So I'm going to move this off to the side here. We don't need the objectives file. The constraint file is one that I want to use. First, I'm going to just comment out this constraint here, which sets the channel flow to 60, because if I left it on for the full simulation, it would force that to be true for every time step. I don't want that. I'm going to click on Save All. I'm going to come over here to my dv.dss file. I don't need the test file anymore. This is the main dv.dss file. I'm going to just rerun this simulation to make sure I have my baseline values back in place. So let's again save. Instead of debug, I'm just going to right click on the launch file and click on run as. Let that run. So that's good to go. Next, I'm going to make an edit to the constraints file. And then let me just paste in the constraint I have here. This is a conditional constraint. It's a soft constraint format, even though I'm using the word constrain right here. Move this over. And what you're seeing is basically the same thing. The goal is called set C12 again. The left-hand side is the flow through channel C12, and then the right-hand side is going to be 60. And if it happens to be the month of September for water year 1923, we're going to set it as a hard constraint. And for every other month, the condition always, we're just going to say there's no penalty whatsoever. Okay. Now, before I run this, I want to not override my existing DSS data, which is here. So what I'm going to do is select all the paths, right click, rename, and then for part F, I'm going to call this base, just kind of as the base case. Boom. And that has been updated. Okay. So back to WRIMS, I'm going to save all and then right click on the launch file and then run. So that'll run. Let's go back to our DSS view, refresh catalog. Okay, I think I have to do this twice sometimes. View, refresh catalog. There we go. Not sure why it does that to me. I'm going to sort by part F, and then for state, I'm going to also rename these 6 new decision variables that were written. Right click, rename, and then let's make part F. I'll just call this alt 1. It's maybe 60 CFS, something like that. And then click OK. All right, those have been renamed. Now I'm going to sort by part B. Let's go ahead and compare the channel flow C12 for our base case and our alternative 1 case where we force the CFS flow to be 60 CFS. Here is the plot. It looks pretty much the same, except for if we zoom in here on 1923. Here's our base case in red, and then it looks like blue is where we force the flow out of C12, out of the reservoir to be 60 CFS. And it looks like the very next month, here's the blue line, the very next month, it basically just released the same difference that it essentially withheld from, what was it, 10.2 CFS. So it released 10.2 more CFS in September 1923, but then the following month it released 10.2 less CFS. So yeah, that's a little bit uneventful, but hey, it's worth looking at. I assume that the reservoir volumes are going to do the same thing. So let's look at SRES1 for the 2 different cases, the base case and then our alternative. And then let's open up the file here. Here's the image, and I'm not really sure where it is. It's 1923. Okay, September. Here it is. So here's just like I thought, a small deviation where the red line here is our base case, and then the green line here represents the storage in the reservoir for our alternative 1. So it released a little bit extra in September. That's why this line is lower. And then it reassumed the exact same reservoir volume the following month by not releasing as much. All right. Well, that's all I had prepared for this lesson. What we did was create a alternative by forcing a channel flow to be a specific value on a certain time step, and then comparing the objective function value as well as the plots to see how this alternative compared with the base case.